Hey, thanks for clicking on my video. If this video helps you, please consider liking this video and subscribing to my channel. It is greatly appreciated and it really helps. Let's get to the video.
Hello everyone, in this video we're going to talk about how we can solve some right triangles. So now what do we mean by solving a right triangle? We just want to find all of our unknown side lengths and all of our unknown angle measures. So in the end we should have 3 side lengths and we should have 3 angle measures. Now one of those angle measures is definitely going to be given to us because it's a right triangle, so it's 90 degrees. And also, more than likely, you're going to be given another acute angle. In this video, we are going to. Later videos that we might do, you might not, especially if you're working with the law of sines or law of cosines. But for right now, we're going to focus on 3 examples. The first 2, notice we have some special right triangles. So for number 1, we have a 30, 60, 90 right triangle. So we know that's 60 degrees, right? So we have our all 3 of our angle measures, so 30, 60, and 90. We have our hypotenuse, which is 12, and we have x and y, right? So now, we can solve this if we remember our special 30, 60, 90 and what the sides are supposed to be and the relationships and all of that. But we could also use our cosine or our sine ratios that we looked at in our previous video, and that's actually what we're going to focus on today because we're kind of going from that previous video. So if I look at my 30 degree angle, let's say I want to solve for x, which would be my horizontal side here, then I know that if I used y over 12, x, I want to solve for x. If I did x over 12, that's my adjacent side over my hypotenuse side, which would in this case would be cosine. So I could take cosine of 30, and I would say that is equal to x over 12. Now, cosine of 30, it's a special trigonometric ratio for a special angle. So cosine of 30, we know to be root 3 over 2. So now we have this proportion, root 3 over 2 is equal to x over 12. So now we can just cross multiply. So we get 2x is equal to 12 root 3. And then we divide both sides by 2, and we get x is equal to 6 root 3. Okay, so x is 6 root 3, so we'll add that in right here. X is 6 root 3. And now we can go ahead and use our special 30, 60, 90 ratios for our side lengths. So we know that our hypotenuse is 12, our longer leg of our right triangle is 6 root 3, and so our shorter leg should be 6 root 3 divided by root 3, or in other words, y is just going to be 6, okay? All right, so now we have our 3 side lengths. We have y is 6, x is 6 root 3, and our hypotenuse is 12, and then we have our 30, 60, 90 right triangle, okay? All right, number 2, we have a 45, 45, 90, so we're solving for x and y, but we also know that x and y are going to be the same thing, right? Because they are both opposite of 45 degree angles. So let's just say we want to solve for y first. Really, it doesn't matter because if I want to work with this angle, then I can do cosine x over 6. I could do sine y over 6. If I want to work with my top angle, I could do sine, which would be x over 6, or cosine, which would be y over 6. So it really doesn't matter. Just pick a starting point and go for it. I'm going to go ahead and do sine of 45 is equal to x over 6, right? And so I know now that sine of 45 is the same as root 2 over 2. And so now we have cross multiply 2x equals 6 root 2. We divide by 2 and we get x is equal to 3 root 2. So if x is equal to 3 root 2, then y would also be equal to 3 root 2. All right, and number 3, now we have a 34 degree angle. So now we're actually gonna have to use our calculator for this one because we can't rely on our special 30, 60, 90 or 45, 45, 90 trig ratios. So let's jump into this one. All right, so we know that we have the measure of angle A because this angle is opposite of side A, so that'd be angle A. Side C is opposite of our hypotenuse, which is our 90 degree angle. So we just need to find, number 1, we need to find the measure of angle B, which would be our angle up here. And then number 2, we need to find out what A is equal to, and then we also need to find out what C is equal to. So those are the 3 missing pieces that we have for our right triangle. So now let's just start with the angle. If this is a 90 degree angle, it's a right triangle, then our 2 acute angles should add to 90 as well. So we could just do 90 minus 34, and we're going to get an angle measure of 56 degrees. So we can add that in there. Okay, now from here on out, let's rely on the given angle that was given to us, 34 degrees. And let's try and find side A. So if I want to find side A, notice I have opposite over adjacent. And so that's going to be our tangent ratio. So we're going to say tangent of 34 is equal to A over 13. And now we can just multiply both sides by 13. Okay? So now I'm going to bring my calculator onto the screen, and I'm going to do 13 times tangent 34. Now be careful with this. First thing we want to make sure is that our calculator is in degree mode. So notice up here at the top of the calculator it says degree. If yours says radians, we want to change that. So you're going to go to mode, and then down here looks like the third option, maybe the fourth option. So the first one is math print, normal, float, and now here we're at radian and degree. So if yours looks like that, where radian is highlighted black, we want to go up to that, go over to degree and hit enter, and now we can just hit clear to go back to our home screen, and now we should see degree at the top. So now we can just type in 13 tangent of 34, and we can close that parentheses if we want to, and we hit enter. So I'm going to round this just to the nearest, let's say, hundredth. So let's call this 8.77 for A. Okay, now we could technically use Pythagorean theorem here, but if we do that, we don't want to use 8.77 for our side length because that is a rounded value. So technically you would use 13 times tangent 34. So I would just not use Pythagorean theorem and use another trig ratio to find out the measure of side C. Okay, so now if I know C, or if I work with 34 again and I see 13 there, that would be my adjacent side over my hypotenuse. So that would be cosine of 34 is equal to 13 over C. All right, so now I just want to solve this for C. So if I multiply both sides by C, so we're going to cancel that there. So now we have C times cosine of 34 is equal to 13. And now let's divide both sides by cosine of 34. So now I know that in my calculator I need to do 13 divided by cosine 34. So 13 divided by cosine of 34. And that's going to give me 15.68. So 15.68. All right, and so now we have all three sides, we have all three angles, we have solved this right triangle. So that is how you can solve right triangles.